Lecture number 19, alternative energy resources, and we will be talking about the solar power today. We would be actually discussing the theoretic about our courses, and obviously when the classes start in campus, we will be talking about the combined cycle power plant in face to face. Um, Starting with the Industrial Revolution in 18th century, the fossil fuel, which include the coal, petroleum, the natural gas, that was the main horsepower of industrialization. That include the generation of electricity to heating and cooling of the building, from cooking to the hot water drinking, from lighting and many electronic devices. The would main actually the main source of that thing was the energy resources from the fossil fuel. Uh, but during the last 1.5 century, for say like 1.5 century, around the fossil fuel which was stored in the earth during the millions of years was rapidly depleted, and now the mankind is again looking for some alternative to these resources. By alternative would mean like anything which would be the alternative to the fossil fuel. This alternative, the word alternative and the renewable, they are interchangeably said. Although in alternative resources, we can actually talk about the nuclear resources or nuclear fuel, but that's what actually we cannot call it as a renewable fuel as well. So alternative normally are used alternative energy resource are normally used for the fuel which is obviously sometimes renewable as well. This include the solar energy, the wind energy, the hydro, geothermal, biomass, tidal, and these are what we call it as the alternative energy resources. And obviously, these resources are mostly even they have got low carbon footprint, have got less higher carbon emissions, and obviously that play a little bit less role in global warming. By in 2000 by 2014, I would say renewable energy sources such as wind, geothermal, solar, biomass, and burn fuel gas, burn bio waste biomass. They provided around like 19% of the total energy consumed worldwide. In these 19%, the electrical share was actually in the renewable share was 22.8%. Most of that was coming from the hydro, which was having 16.6%, and obviously by wind, which was 19, around like 3.1%. Um, According to the REN 21, which is actually the global report about the renewable energy, um, in 2017. This figure, the total renewable figure was actually increased by 19.3% for the energy in 2015 and 24.5% for the electricity in 2016. Uh, there are many places around the world with a grid that are run almostly exclusive on the renewable resources. So the question arises whether we would be actually or whether we would reach towards the 100% renewable or not. Uh, a study in Stanford University or UC Davis University analyzed the current state of renewable technology with an eye to see if we could feasibly complete run the world with renewable or not. The study look at the world where it's say almost 90%, if 90% of the energy demand would be met with the large scale wind and solar generation. Um, and yes, on the and the remaining 10% would be 4% would be provided by the geothermal resource and electro hydroelectric, while 2% would be from wave and tidal, and the remainder should be from the fuel cell as well. They also foresee for the need of keep conventional power plants system until they could be replaced with the renewable power plants. By 2030, they say like the new power plant should be the sources or the source of the new power plant should be the renewable. by 2050, they say like all existing power plant could be readily converted to renewable alternative, completely the 100% conversion plan. University of Pennsylvania generally agreed to this one and also quantified some of the estimates as well, like quantifying like how we would reach towards the 100% renewable energy. So that by mean like if you are looking at the 100% renewable energy for the total world, you would need around like 3.8 million large turbines, around like 90,000 utility scale power plants, around 9,400, sorry, 4,900, 490,000 of tidal turbines, around 500 plus of the geothermal installation, and 900 around like hydroelectric plants. Um, yes, but if that is feasible or not, that would be one of the question, and that's what actually they have studied on. But at the national level, some of the nation, like around 30 of the nation, they have achieved more than 20% of their supply, electric supply from the renewable resources. Um, and the most of them, the country that use most of the renewable energy is the Iceland, which actually utilize 100% of the renewable, and that mean like they are actually, and that's because they have got abundant geothermal energy that is utilized in the renewable. Next up is the Sweden, which actually say like they would be pushing their own self for the 100% renewable, and obviously they are looking at the investment which is actually under the renewable sources. Um, Next, close to the third place was the Costa Rica, which actually with an impressive 99% renewable resources, and that was achieved in 2016. And they say like by 2021 they would be actually looking at the 100% renewable energy. And finally, they are the fourth place, Nicaragua, and that is actually with 90% of the power plants or the power generation is the renewable, and obviously that's because of their solar and wind generation. Um, all these nations, obviously, if they say like when there is a will, there is a way. Obviously, so if you want to have any renewable resources or you want to have a renewable power plants, so obviously you want to invest on it, and that's what actually we are saying like that would be one of the things which would be looking for the 100% renewable world. Now, in renewable energy, one of the biggest or one of the main contributor in the renewable energy is the solar energy. So according to the well-established measurement, the average power density of the solar radiation just outside the Earth atmosphere is around like 1366 watt per square meter. That's what we call it as the outside the Earth uh, atmosphere. That's what actually we incident on the Earth atmosphere, widely known as the solar constant. The definition of meter is actually 10,000, 1 by 10, 1 over 10,000, 1 million of the Earth's Mediterranean from the North Pole to the equator. So that by that definition, that means like the total power that would reach the Earth would be 1366 multiplied by 4 by pi into 10 to the power 14. So that come up as 1.7 into 10 to the power 17 watts. If you multiply with the seconds in a day, average day, and each year having this much of the days, so the total power that is incident on the Earth during the year is 5.46 into just about 24 joule. That means like 5460000 error joule per year. So how much this energy is? If you're looking at the total consumption in the year 2000, annual total consumption in the year 2005 and 2010, so that is actually around 500 arajoule. So that mean like if we may like it was just a mere of 0.01% of the annual energy of the solar energy that is reaching the earth, that can satisfy the need of the entire world. So that means like if we can even harness 0.01% of the solar energy, this which is actually incident on the earth, we can actually satisfy the need of the total world. So that means like if we are looking at the energy and solar energy, that's quite a big contributing factor in the renewable energy resources. But yes, the total energy which is incident on the atmosphere surface that does not reach inside the Earth surface. So mostly around 50% of the energy is reflected back. Some of them is actually reflected in the cloud and atmosphere. Some is reflected by the Earth surface. Uh, some of them is actually absorbed by the Earth. So the total actually the total energy which is reaching the Earth surface, it is actually around like 166 watt per square meter. So that means like it is around like 0.6% that is net absorbed. However, if we are looking at this one, the average solar radiation absorbed by the Earth's surface is 163.3 watt per square meter, or roughly around 170 watt per square meter. So this is the total energy which is actually absorbed by the Earth's surface. Um, Now looking at the energy perspective of the Pakistan. So Pakistan has some of the highest value of insolation, which we call it as incident solar radiations. It is around like 5.3 kilowatt per square meter per day, with the jacket above receive like 2142 kilowatt hour of solar radiation per square meter per year in the world. Uh, so we have got highest value of insolation, which is 5.3 kilowatts, uh, with the 8 to 9 hour of sunshine per day. Ideally, that's what we call it as the ideal climate for the solar generation. But yes, being a solar quite a good value of insolation, still the technology adaptation in Pakistan is quite slow. The country has got solar power plant in Pakistan, in Kashmir, Punjab, Sindh, and Balochistan, but obviously it's a quite a slow process. What we have seen from last few years. Uh, yes, but back from 2013, there is actually quite a good number of projects which was started by the government. Yes, and one of them was actually the Qaid Azam Solar Park, which was in the Cholistan Desert. That was actually started by 2017. Sorry, that was supposed to start by 2017 with 1 gigawatt of the power. But yes, it could not reach that size. But still, what we have got is around like 400,000 panels installed in a Kadazim solar park with a capacity of 100 megawatts. Um, the southern western province of Balochistan and north of Sindh, if I would just reach out like over here, so they have got the excellent condition for harvesting solar energy, and most of them is actually somewhere here, which is actually somewhere around Chari, Quetta, Kila Abdullah, Kila Saifullah. They have got quite a huge number of solar radiation over here. But even despite of the favorable condition, the use of solar energy for the electricity generation, that's quite low. There have been like certain small project by Alternative Energy Development Board, or the PRECREC, which is mean like Pakistan Council for Renewable Energy Technology. They have electrified. They have actually provided few of the projects, but most of the projects are the small scale projects, and that does not contribute to much of the solar energy share in the Pakistan energy mix. Yes, that's what we're having said that. Uh, Being a favorable condition of solar energy, Pakistan must actually invest on the solar energy technology. Like for example, even if I would just say like if we have got a good average solar insolation, which is actually 170 watt per square meter, which is actually what I mean to say like Pakistan have got much higher than this value. But if we just take the global average, which is 170 watt per square meter, these the surface area of Pakistan is 796 into 10 to the power 11 square meter. So the total power, solar power that is incident on Pakistan, the surface of the Pakistan is actually 135 terawatt. So it is 600 times the total power consumption which is right now in Pakistan. That mean like if we can actually take some of the energy out of the incidence energy, or if we can harness some of the solar energy which is actually incident on Pakistan, so we can actually solve many of the our electricity problem, or what we call it as a power consumption problem. Um, Now, we have already introduced what's the use of the solar energy, what would be required for the world and what would be required for Pakistan. Let's talk about the solar energy itself. What are the solar energy system we are talking about? So mainly there are two different kind, two main type of the solar energy system. One is solar thermal and one is photovoltaic. Solar thermal, uh, in solar thermal we are looking at the direct heating, cooking, drying, power generation, while for photovoltaic, which we normally call as a PV technology, they are actually used for the electricity generation. Um, this is what actually a little bit chart for the solar energy utilization. So solar energy, if I'm also looking for the direct solar energy, they are utilized in two different forms. One is active utilization and one is passive utilization. The passive utilization, and normally if I would say like thermal and illuminative, actually they are mostly in building and architecture. They are utilized in building and architecture. That, for having said, if I would say like in winter time, if your window, your glass window is facing towards the sun, so that means like it will be heating your room. And in the summertime, if it obviously facing away from that one, so that means like it will be actually a little bit cooled down. uh, so that means like it's a little bit what we call it as a passive technology. uh, while for the active technology, we have got the solar thermal, photochemical, and photovoltaic. That's what actually we have so much of them. Even all these three have got two different now, two different subsystem, which we call it as a unconcentrated system and concentrated system. Whether we are actually concentrating the incident solar radiation on a surface, or we are not concentrated. So this is what actually we have got. So the unconcentrated one, we have got the solar thermal power station, we have got cooking, we have got energy system, solar pound, electric, thermoelectric processes. For the concentrated one, we have got concentrated solar power and chemical conversion. Uh, for photochemical, artificial photosynthesis, and so on, so forth. For the photovoltaic, we have got conventional photo, which is unconcentrated PV cell, and we have got concentrated PV cell. So this is what we call it as the utilization of solar energy, or we call it as the solar energy systems. In this lecture, we will be talking about few of them. So let's start with the solar thermal. So solar thermal energy is a form of energy and technology for harnessing solar energy to generate solar thermal energy or electric energy for use in industry or in a residential or commercial sector. The first installation of solar thermal energy was actually at Sahara Desert, approximately around that was around 1910 or 1912 somewhere, when a steam engine was run on a steam produced by sunlight. Because at that time the fuel was cheap, there was abundantly coal available, the hydrocarbon was cheap, so that means like it was not actually so convenient to run that one. But only after a few decades, about like 1970s, it was revisited, and obviously the utilization of solar energy was quite actually possible. Solar thermal can be utilized both in active and passive wise. That's what actually we have said, including concentrated and non-concentrated system. That's what we have discussed. Solar water heating. Solar water heating is a heating of water by sunlight using solar thermal collector. So there are a variety of different configuration available that should be cost effective and that should provide solution to different climate and latitude. Solar water heating, that they are used both for residential purposes and industrial application as well. So that means what is actually a solar water heating, or what actually we do in a solar collector, thermal collector. So the sun facing collector. So if we have got a sun over here, so the sun facing collector has a working fluid that passes into a storage for a later use. So let's say we have got a storage over here, temperature controller and storage somewhere. So we have sorry, over here. So we have got a storage solar water tank that could be used for the storage of the water. Solar water heater can be active. That mean like it can be pumped. That can be passive, and that mean like it should be conventional. They use water only or water plus some working fluid. They can be directly heated or light concentrated mirror. They can be independent or hybrid with electrical heater. In a large installation, mirror or what we call is that a reflector as well may concentrate solar sunlight into a small collector. Uh, as of 2078, global solar hot water uh, thermal capacity thermal capacity is 472 gigawatt, and our market is mainly dominated by China, United States, and Turkey. Barbados, like Austria, Cyprus, Israel, and Greece, are the leading country by capacity per person, which means like they are utilizing the solar hot water too much. What actually they do, what is actually solar water heater look like? Evacuated tubes which are connected to the pressurized tank. The cold water is in we have got the inlet of the cold water in the pressurized tank, which is actually going down into the glass tubes and recirculated into the evacuated tube by absorbing heat into the black collector. Um, when the water is actually hot, it is actually drained out from the hot water outlet. We have got a double pan glass as well to trap energy, which is actually radiated from the glass. If you are looking at the flat panel efficiency, the transmission that would be through glasses would be 85%. Absorption by black sheet is 95%. Radioactive loss is actually 30%. Convection and conduction loss is 10%. So if you look at the total efficiency of this one, we have got 55% of the total efficiency of this flat panel water heater. But still, as we are saying, like there is a solar energy, and obviously solar energy is quite free. So 55% efficiency is quite a good efficiency. Uh, there are like some interesting fact around about these solar water heater as well. Like in early 1980s, there was oil prices in the United States. So obviously they offer tax credit for the installation of solar panel. So they were normally essentially free for them. Many unit was installed until the program was dropped in the 1985. But most of them was actually used to heat the swimming pools. So that was the case of the United States. But other part of the world, as we have discussed, like there are some leading countries in the world in solar water heating. So 95% of the homes in Cyprus, sorry for the spelling. So 95% home of the Cyprus are actually having solar water heating, while 65% of the home in Israel, they are having the solar water heating. The next in line is actually the solar cooker. Um, Solar cooker is a device which uses the energy of the direct sunlight to heat and cook or pasteurize drink and other food material. Many solar cooker currently used are relatively inexpensive, low technology devices, although some are powerful and expensive, a traditional one, but most of them are actually used by the what we call it as the uh, not so developed countries, mostly in India and other parts. The cooking time depends primarily on the equipment being used or the amount of sunlight at that particular time, and the quantity of food that need to be cooked. Air temperature, wind, and latitude also affect the performance. There are several types of the solar cooker. The main are like these four types. This is one of the solar panel, sorry, the panel solar cooker. You can imagine there are some reflective panels over here. The solar the panel solar cooker use reflective panels to focus sunlight on the pot, which is actually placed inside in between the cooker. These work best in tropical climate or in the warmer month when wind and heat losses are not so much. And inexpensive aluminized cardboard normally are used, which actually can take up like temperature to around like 450 degree Fahrenheit. Uh, th- this is plenty since food normally starts around like 180 degree Fahrenheit. Normally, if you are using the aluminum foil solar cooker, uh, it gets a little bit after a few weeks it gets oxidized and turn black. So you have to replace that aluminum foil back. But obviously, they are so cheap in many places that this is normally one of them, like quite a low end solution to a cooking. Then we have got same kind of a thing, which we call it as a box solar cooker. The box cooker has a transparent glass or plastic top, and it may have traditional additional reflectors, what we call it as reflector. Somewhere here, if we install another uh, reflecting material, so it will be reflecting the sunlight back into this one. So that means like we have got another additional reflector to concentrate the sunlight into the box. The top can usually be removed to allow the dark pot mm, containing food to be placed inside. Um, Normally, like the solar box cooker typically reach temperature of around like 150 degrees centigrade or 300 degree Fahrenheit. Uh, that's definitely not as hot as the normal oven, but obviously is quite enough hot enough to cook food if we are looking at the longer time. So this is what we call it as a box type of solar cooker. Then we have got a parabolic reflective solar cooker. Normally these are the large solar cookers, and obviously these are the what we call it that the high end or the high tech solar cooker. When this point is so we have got a parabolic solar cooker concentrated sunlight to a single point. So we have got parabolic dish, and which is actually reflecting sunlight on a single point. We call it a focal point. When this point is focused on a bottom of the pot, it can heat the pot quickly to very high temperature, which can often be comparable to temperature achieved in a gas or charcoal grill. These type of solar cooker are widely used in a several regions like in China, India, with hundreds of thousands of families currently use parabolic solar cooker for the preparing the food and heating water. Normally, in the northern India, that's quite common actually. The advantage are speed and potential to cook when it's cold outside. It's still when it's still cold outside. The disadvantages are the safety concern because it's reflecting the light to a focus on the single point. So obviously it's a little bit not so good for the eyes and the children. Um and obviously you need to stir the content just like a normal pot because it will be actually sticking to the stove top. Temperature, yes, obviously it can reach up to 400 degrees centigrade, sorry, 400 degree Fahrenheit. The parabolic cooker might also need adjustment to obviously to face towards the sun. The next, which is actually the Dune technology, is the vacuum tube solar cooker. Obviously, the evacuated solar cooker are essentially a vacuum seal between the two layer of glass. So obviously, we have got a glass, and inside that glass, we have got a vacuum over here. The vacuum allows the tube to act both as a super greenhouses and an insulator. The central cooking tube is made from the borosilicate glass, which is resistant to a thermal shock and has a vacuum beneath the surface to insulate the interior. The inside of the tube is lined with the copper, stainless steel, and aluminum nitride to better absorb and conduct heat from the sun rays. The vacuum effect helps to hold the heat, and obviously internal temperature can reach up to 55 degree Fahrenheit, as hot as obviously the gas power grid. This is all about like the solar heating and solar cooking. We would be actually continuing with this our solar power in the next lecture as well.